Okay, so average rate of change. A change in a quantity over a period of time is the amount of change divided by the time it takes. Okay, this is nothing mind-blowing. This is something you've been doing since Algebra 1, if not prior, when you started talking about slope of a line, because really that's all calculus is. We're just analyzing slope of a line, but we're doing it in multiple different ways and using that in different ways, okay? Average rate of change, if you were thinking like average speed, you would figure out how many miles you went and divided that by the number of hours it took you to go that long. Okay, so it give you an average speed. What your speedometer is telling you is your average speed, essentially. Okay, so again, this is nothing crazy, nothing out there, but average rate of change is how we're going to build into what's going to be called instantaneous rate of change, which is the calculus piece. But this is nothing to look over either, look past. Average rate of change, most likely I'm going to ask you a test question about average rate of change, and we don't spend as much time on it as we do as instantaneous rate of change, and so often students overlook that. So do not overlook average rate of change thinking it doesn't mean as much as the other stuff. Okay, so let's do an example for average rate of change. If I want to find the average rate of change of this function, x cubed minus x, over the interval 1 to 3. So again, the interval 1 to 3. So if I were to graph that function x cubed minus x, it's going to look like this nice curve. I'm simply trying to find the average rate of change from here all the way up to here. Okay, from 1 to 3, I want to find the average rate of change of this function. Well, in order to find average rate of change, I could simply connect those points with a line and find the slope of that line. So if I connected those 2 points with a line, if I find the slope of that line, that is average rate of change. Okay, so slope is average rate of change, so that's slope m. And we'll specifically call this a secant line. Don't get this mixed in with like secant as trig functions. I mean, they are related, but this is called a secant line. When you just connect 2 points that are lie on a curve, the slope of the secant line is the average value. Okay, so if I want to find the average value of this, I mean, it's just slope, so it's change in y all over change in x. So if I figured out my change in y, well, I'm going to take my functional value, so I want to figure out what f of 3 is. So that's going to be 3 cubed minus 3. What is 3 cubed? 27. Minus 3 to get 24. And then I also have to figure out f of 1. F of 1 is just going to be 1 cubed minus 1. And so that's going to be 0. So my change in y is 24 minus 0, all divided by my change in x, which is 3 minus 1. 24 divided by 2, so I'm going to get 12. And that means the slope of this line is 12. Okay, so average rate of change is the slope of the secant line. So if I find the slope of the secant line, that is the average rate of change. Okay, so it all comes back together. Okay, so you're going to have some classwork problems on this. And again, this is not to be overlooked. This is building into our instantaneous rate of change, but be ready for a question like this to be on the test. So average rate of change is simply the slope of the secant line. All right, now let's talk about tangent to a curve. So we cannot find the slope of a curve. All right, that's not a thing. You find slope of a line, like that secant line was a straight line, we can find the slope. If I want to look at slope of a curve, the best I can do is evaluate this at some point. So if I had some curve going on, it's not a big curve. If I had some curve going on, I could pick a point and then I could draw in a tangent line, which is just going to pass through that one single point on the curve. and then I could find the slope of that tangent line. Okay, so you cannot actually find the slope of a curve. All you can find is the slope of the tangent line that's tangent to the curve, meaning it's only touching one point on the curve. Okay, all right, so let's build this. We're going to build this big function that we're going to work with. So suppose I have some curve going on. Let's make it look like that. And on my curve, I have some point P, and I have some point Q. Right? If I wanted to connect these with a secant line, I could find the average rate of change. Okay? If I wanted to find tangent to the curve like I have here in the upper right of the screen, I essentially have to get those 2 points almost right next to each other, connect those 2 points into one, and then I would have just going through 1 point. So let's see how we can do that. Let's say my point P here, let's go over some distance, we'll just call that A. Well, then the y coordinate here at this point, I'll just say is some f of A. Okay, if I had some function for my green line here and I evaluated at A, I would have f of A. So the coordinates of P is A, comma, f of A. Now from A on the x-axis, I'm going to go some distance that I'm going to call h. I'm going to move some distance to the right from A, and that's going to get me to a new x-coordinate that I'm going to call A plus h. So if I was at A, I went some distance h, it's A plus h. The y-coordinate then of Q is f of A plus h. So I have a x-coordinate of A plus h, and then a y-coordinate of A plus h. Okay, so to find the slope of my tangent line, if I know my slope m, is simply going to be my change in y all over my change in x. Well, now I want to think of this Q is sliding down the line, and I'm getting closer and closer to my point P. So that way I can draw my tangent line, and it's only going to go through one spot. Okay, so if I think of my change in y, well, y is coming from, my change in y is going to be, let me get too many lines on here, I'm going to erase this one. Oh, not that one. If I wanted to recognize my change in y, that's simply going to be f of A plus h, my y2 essentially, if I think of this as y2, minus f of A, which was my y1. All divided by, in this case, my x2 is A plus h, and then I'm going to take this back to my x1, so minus A. So my numerator is f of A plus h. My second piece is this f of A. A plus h minus A leaves me with just an h in the denominator. All right. And how I want to evaluate this, I'm going to say my limit as h approaches 0. H approaches 0 means as I'm moving this Q down the green line, this distance h that I have here in red is getting smaller and smaller and smaller. So how I say h approaches 0, I'm trying to get those 2 points to eventually lie on top of each other. Okay, so using limits as h approaches 0 now of my function, f of A plus h minus f of A all over h is the function that we're going to use. Okay, this is how we find the slope of a line tangent to a curve at some point P. All right, there's a lot of A's and H's and everything going on, but simply just think of it as y2, x2, y1, x1. Okay, all we're doing is slope. Okay, so here officially that limit as h approaches 0, f of a plus h minus f of a all over h is the one that we're going to be working with. Yeah, bring it. Okay, so again, why h approaches 0, because I'm trying to make this distance between a and a plus h smaller and smaller and smaller. So I'm trying to make my distance essentially be 0. And so that's going to bring this q down the line because I want q to line up on p. So it's saying h approaches 0, that distance I want to make closer and closer to 0. All right, let's actually do one. So let's let f of x be the function 1 over x. We want to find the slope of the curve at x equaling some a value. So they're not telling me what x is going to be. It's just going to be some a value. So our answer is going to be a function. Okay, well, I know in order to do this, I have to use my limit definition, f of a plus h minus f of a all over h. Okay, and I know f of x equals 1 over x. All right, not part of the problem. I'm bringing this in. If f of x is 1 over x, what's f of 5? We know our function f of x is 1 over x. How would I evaluate f of 5? Yeah, so this would be 1 over 5. If I said f of t, this would be 1 over t. I can put whatever I want in there. So what is f of a plus h going to be? 1 over a plus h. What is f of a going to be? 1 over a. Okay, so now I have those two pieces because this is a plus h and this is f of a. So now I have 1 over a plus h minus 1 over a, and I'm doing my limit as h approaches 0, all over h. Is everybody comfortable how I got to that point? Okay. How do we subtract fractions? Common denominator. Okay, so if I want to find a common denominator of this, I'm going to multiply this by a plus h all over a plus h. And I'll multiply this by a and this by a. So now I have my limit as h approaches 0, and I'm going to do it up here just to make it a little bit easier. So on the left, I would have had a all over a times a plus h. And then I'm going to have a plus h all over a times a plus h. So my common denominator is that a times a plus h. But my numerator is going to be a minus h, because I'm subtracting that quantity in parentheses. Well, a minus a is 0. Doesn't matter. 2 minus 2 is 0. X minus x is 0. A minus a is 0. But I still have this negative h. And then my common denominator of a times a plus h. Okay, that is only the numerator. We still have the denominator here of h, but now in my numerator I have that negative h, a times a plus h. Good to this point, all we've done is subtract fractions. Okay, it's looking like a lot of variables, but it's going to get better. Okay, all right, so if I have a fraction in the numerator divided by something, well, really, I could think of this as h over 1. So if I'm dividing a fraction by a fraction, I can think of invert and multiply. So this is really 1 over h times negative h a times a plus h. Okay, so all I did was multiply by the reciprocal of the denominator. Let's do some rewriting. I'm going to rewrite this as negative h over h times 1 over a times a plus h. Still equivalent, okay, because in the numerator I have 1 times the negative h. Well, in the one below that I have negative h times 1. Still equivalent. But what is negative h divided by h? Negative 1. Okay, this goes to negative 1. And so really I have negative 1 times my limit as h approaches 0 of 1 all over a times a plus h. Can I evaluate that with substitution? So as h approaches 0, if I put 0 in for my h, this becomes 0. And so all I have is a times a. All right, so it's getting kind of messy here. But my final answer then, I've done all my limit stuff, so I don't have that anymore. I have negative 1 times 1 over a squared. And so that just becomes a negative 1 all over a squared. Ask me questions if something does not make sense. Okay? So this, I mean, there's a lot going on in here. Okay? But just take it step by step and slowly work through it. So again, find the slope of the curve at x equals a. I actually end up with a function. You tell me any a value. You tell me 1, you tell me 100, you tell me negative 17. I can tell you exactly what the slope is of the curve 1 over x at that value. So we end up with a function as an answer. Okay, so negative 1 all over a squared. Let's use that. So this is the graph of 1 over x. Now I know my function, my slope of the tangent line. The slope of the tangent line is that function negative 1 all over a squared. Okay, well, I want to know where does it equal negative 1/4. So I'm trying to set this equal to a negative 1/4. Okay, when do I have a slope of negative 1/4? Not at the point negative 1/4. When do I have a slope of negative 1/4? So I'm going to set my function equal to what the slope should be. How do I solve this? How can I solve this for a? Lena, what do you say? Speak up. Well, what would you do? What method? There's multiple methods you could do, but which method would you do? Cross multiply? Yeah, let's cross multiply. Okay. All right, we're going to cross multiply. And so we would have a negative a squared equal to a negative 4. Yep. Yep. Ryan, you're going to be released at 140. Okay. So negative a squared equaling negative 4, well, I can think of if I were to solve, if I were to add 4 both sides, I'd end up with positive 4. You do the same, add a negative a squared to both sides, end up with just a squared. So therefore, what is a? Brady says 2. What about negative 2? Do not forget the plus minus. Okay? So a is plus or minus 2. So that means here at negative 2 at this point, and here at positive 2 at this point, my slope of my tangent line will have a slope of negative 1/4. So all that work we did to find the function lets us do it for, now we can figure out anywhere where it's going to occur at. Okay. All right. Now let's get into some terminology, some word, not really terminology, more wording. That's why I said a lot of calculus is understanding what exactly the problem is asking. Once you understand what it's asking, the math becomes easier. If you don't understand what it's asking, you don't know where to start. If you see this wording, the slope of y equals f of x at x equals a. That means the same thing as the slope of the tangent line to the function y equals f of x at x equals a. Okay, if you see either of those forms, they're talking about the slope of the tangent line, and that's what we're going to focus on all year is tangent line. Okay, if I say slope of the curve, well, the curve doesn't have a slope. The tangent line has the slope, but it's an instantaneous right there at that point. I can find the slope of the tangent line, and it depends on which point I pick. Okay, like that last slide where it's 1 over x. If I had picked it at -1, that's going to have a different slope than what it had at -2. So here we go. The instantaneous rate of change with respect to x at x equaling a. This again is just slope of the tangent line. But instantaneous rate of change is what we want to work with. Do not get that confused with average rate of change. They are not the same thing. Average rate of change, again, was that slope of the secant line. This is the slope of the tangent line. So instantaneous rate of change at the instant, at a single point. Average rate of change, we have 2 points. We connect those with a secant line, and we get our slope. The formula, using limits as h approaches 0, of f of a plus h minus f of a, all divided by h. This means the exact same thing, but you can see it written this way. And I think in the Math Excel assignment, they say use the alternate form. This is what they mean by the alternate form. Now it's just f of x minus f of a, but it's my limit as x approaches a of x minus a. Okay, it's doing the exact same thing. Okay, but you might see it written this way as well. We'll do a practice one to show you working it out in this method. So limit as x approaches a of f of x minus f of a all over x minus a. But again, all of these give you the slope of the tangent line, which is what it's going to be asked. Okay, so let's use this alternate form, and let's do the limit as x approaches a of f of x minus f of a all over x minus a. Again, a is just some point on the line, x is just some point on the line, on the x coordinates. Okay, so if we had this one, I say find the slope of the line tangent to the curve, and our curve is x squared minus 3x minus 1, all at x equaling 0. So when x is 0, that's where I want the slope. What's the slope of the tangent line when x is 0? Okay, so from our formula up here, we need an f of x. Well, conveniently, we have f of x. We don't have to do anything. That f of x is the exact same thing that they gave us here. But then we have to do f of a. This f of a is putting in this value. So I could say a is the same thing as 0. So this is kind of, seems awkward at first, but you can think of as a is equal to 0. Okay, x is some distance further down the x-axis. We want to know right here at the first point when x is 0. Okay, So f of a is really saying f of 0. And so we're going to have 0 squared minus 3 times 0 minus 1. So f of a is -1. So my limit as x approaches a, well, I know a is 0, so we're trying to take it as x approaches 0, of f of x. Well, f of x is x squared minus 3x minus 1. I'll put these on school YouTube. Okay, and for these, I like to put them in parentheses so I understand it's this whole piece minus a -1. Okay, it's subtracting those two, and it's subtracting -1. All divided by x minus a. Well, my a is 0, so it's x minus 0. So we can think of this as my, right out with the limit. Limit as x approaches 0 of x squared minus 3x minus 1 plus 1 all over x. At the end there, the subtract 1 plus 1, those ones go away. I don't have to worry about that. -1 plus 1 gets me 0, so I don't have to worry about those anymore. So I have my limit as x approaches 0 of x squared minus 3x all over x. But I can't do a direct substitution here. If I put 0 in, I get 0 in the denominator. So let's see if we can factor. Limit as x approaches 0. If I factor out an x from the top, I'll end up with x minus 3. And then I end up with an x on the bottom. That does help me out because this now goes to 1. My limit as x approaches 0 of x minus 3 is going to be -3. So final answer, find the slope of the line tangent to the curve. The slope is -3. So that's using this form. And you're going to do a couple where they're going to ask you to use this form. Doesn't matter, you'll get the same answer, but sometimes one form is easier than the other. Okay, so I wanted to expose you to both. Depending on the problem, sometimes one form is better than the other one. And just by trying it, you'll start to see. All right, one more problem, and then we're done. What is the slope of the tangent line to this curve now, 4 minus x squared, at x equaling 1? So again, that x equaling 1, we can think of our a value as 1. So let's use that first limit definition. So the limit is h approaches 0, f of a plus h minus f of a all over h is the definition we're going to use. All right, so first I have to figure out what f of a plus h is. So f of a plus h would be 4 minus a plus h squared. I'm literally just typing in or putting in a plus h in place of my x in my function. Okay, if I said evaluate f of 2, you would put 2 in for the x and square it. Or evaluating for a plus h, we put a plus h in for the x and square it. And let's change this to 1 right now, because right up here we said a is actually 1. So let's change it to 1 plus h. Let's do it right here from the start. FOIL, 1 plus h squared is not 1 squared plus h squared. We have to actually FOIL that. What is 1 plus h expanded? 1 plus h squared expanded. Kelsey, are you saying it? No. Were you saying it? Lizzie, were you saying it? There's something over here. Paige? What is it, Paige? You tell me anyway. Okay, we got 1 plus h squared, so we have 1 plus h times 1 plus h. So FOIL that out for me, Paige. Fancy, you already flipped them around and everything. Okay, so 1 plus h squared is this. So we're going to have h squared plus 2h plus 1. And now let's go ahead and do some simplifying. 4 minus h squared plus 2h plus 1. And so we're going to have our negative h. Let's stop right there. And then f of a, if we were to evaluate f of a is going to be 4 minus a squared. But we know a is 1, so 4 minus 1 squared to get 3. So let's use all of that here in our limit definition. So my limits as h approaches 0 of f of a plus h, which I found, was 4 minus h squared plus 2h plus 1. All of that minus 3 divided by h. Simplifying the top, I have 4, and then I have my positive 1. Let's see here. Ooh, I made a mistake back here. Nobody caught my mistake. Back here when we were doing the a plus h piece, that should have been h squared minus 2h minus 1. Okay? Back here, I made the mistake. I wrote this as plus 2h plus 1. But remember, we're subtracting this whole quantity, so it should be minus h squared minus 2h minus 1. Let's fix that. Now we should see 4 minus 1 gets us 3, minus 3 gets us 0. So really all we have, the limit as h approaches 0, we have h squared minus 2h all over h. Cannot evaluate in this form because h is a 0 in the denominator, but let's do some factoring. Thank you. Yes, that's negative h squared. Thank you. Good catch. So if I were to factor out a negative h from this top, I would have h minus 2 all over h. These conveniently go to negative 1. So now I have my negative 1 times my limit as h approaches 0 of h minus 2. Oh, that is plus. Falling off my game a little bit here. So then I'm going to have negative 1. If I put in 0, I have a positive 2. So negative 1 times 2 is going to end up being negative 2. Okay, and again, that is the slope of the line, slope of the curve, when x is 1. Okay, 4 minus x squared, we know is that parabola that's opening down. Okay, and the 4 just creates a shift, but at 1, we're going to have a negative 2 for a slope, which makes sense. Okay, because the parabola opening down, it's going to create a tangent line that has a negative slope as well. So all that becomes negative 2 is the correct answer. Okay, part B to this problem. I said one problem left, and 7 parts. Okay, this is the last part though, honestly. This one's quick. Slope of the tangent line to the curve. So we figured all that out. This one's just saying, what is the equation of the normal line? Has anybody ever seen this terminology, normal line, in a math classroom? Normal line just means perpendicular. Okay, normal to the curve just means perpendicular. Okay, so we have some tangent line going on. Well, we're going to create the perpendicular line to that tangent line. Okay, well, we know that our slope of our tangent line at 1 was a negative 2. So what's the slope of the normal line going to be? It's going to be a positive 1/2. and they want us to create an equation of that. Well, to create an equation, we could do a simple point slope form. Y minus y1 equals my slope, x minus x1. Do I know an x and y point on this line, on the curve? We did that a minute ago when we figured out what f of 1 was. Okay, remember we put in that 1 point? Okay, so f of 1 is 3. So I know a coordinate point is going to be 3 comma 1. And so I'm going to have y minus my y, or 1 comma 3. Sorry about that, backwards. So y minus 3 equals my new slope, 1/2, x minus 1. Done. That is the equation of the tangent line. I'm sorry, of the perpendicular line to the tangent line, the normal line. Okay. All right. So 2.4 is in Math Excel. Due Tuesday by midnight. But Tuesday when we come into class, I'll take questions on it, and then we can go from there. But we are going to start reviewing. This is the last section, and this is the hardest section probably, as you've seen.